there are two different kinds of numerical values. There are integer data types and there are double data types, which are real numbers. And because they're encoded differently, there are rules about how they interact. And it's usually pretty intuitive, but sometimes it's not. The idea is that if you do math with two different integer values, the result will always be an integer. If you do math between two double values, the result will always be a double. And then if we mix an int and a double, the result is going to be a double because you can kind of represent smaller pieces with a double, and so it feels like you can preserve more precision that way. So the only way that the result will ever be an integer is if you start out with two integer values. So for example, if I say system, so this is going to be really intuitive. If I have one integer and I add another integer, obviously the result is going to be another integer, right? So that would end up being the number 10. I'm not even going to do it because it's so obvious. But what if I took two integers and I divided them? Think about the rule I just gave you. What if I take the integer, second integer, which is a 7, and I divide it by a first integer, which is a 3? What is the answer going to be? Well, in math class, you know that this ends up being a real number with a fairly large decimal component, right? But the rule in Java is that when you divide two integers, the result must be an integer. So what happens is in Java, you always truncate when you have two divisions, and this is called integer division. So the result here is just going to be a 2. Watch this. And sure enough, there's a 2. Okay? So you have to be very careful when you divide two integers that you know it's not going to divide perfectly. It's going to be the number of whole times that the divisor goes into the dividend. Now, if you want the answer to be a double, what you can always do is cast. Okay? Casting says, please quickly change this data type into another data type. So maybe what I want to do is cast my divisor into a double. And the idea, the way you cast is you use parentheses, and then you write a data type that Java recognizes inside, and that means it's going to change the value immediately to the right into this target data type. So first integer is an int value, but Java will turn it into a double before it goes and does this this math. So now if I divide these two things, the result will be a double. And there we go. Now we get the long decimal component. This is actually interesting. I should point this out. We know what should the actual decimal value be. It should be 33333 all the way for infinity, right? It's 0.3 repeating. We're dividing by 3. Look at this. Java thinks that it ends in a 5. That is clearly wrong, okay? It's clearly wrong. This is a problem with doing math using ones and zeros. The representation of this decimal is not infinite. It's finite, and therefore there is inherent what we call round-off error, and this will be on tests and quizzes. Sometimes when you do division, actually when you do any kind of math that is based upon double values, real numbers, you're going to have a small amount of tiny round-off error because you're only using 64 bits. So once you run out of bits, you can't go on forever, and Java starts rounding those tiny valued bits off. And we'll talk about what you have to do later, but just be aware that there's some error. The field of mathematics deals with infinite data sets. I mean, you're constantly dealing with infinity. How many integers are there? How many real numbers are there? How many rational numbers are there? And we can just very casually say, oh, there's an infinite number, and we move on. But in a computer, you're dealing in a finite world. There's a finite number of bits that your computer can manage. It's a very large number, but it's finite. And so we come across problems like these. And so you have to manage that issue. All right, let's go back to what I was originally talking about. Good, so that's integer division, so you have to be careful of that. So here's an example of we're going to take an integer value and we're going to add it to a double value. Java, there's no clear preference as to what data type we want, and so Java defaults to the data type that keeps the most precision, which is a double. So we're going to take this value of 3, we're going to add it to a value of 1.2, and the answer should be, I guess, 4.2. And yes, it is. There's 4.2. Okay, so we've talked about casting data, we've talked about integer division, we've talked about round-off error. There's another kind of error that you can get when you're dealing with the fact that we're dealing with a finite world. Okay, so I'm going to make a really big number. Okay, I'm going to create an integer called power. I'm going to start it out at 2. I'm going to create this thing called a while loop, which is pretty straightforward. You'll understand. It's basically, I'm going to say while exponent is less than 40, I'm going to do two things. I'm going to print out the power. Then I'm going to tell the power to multiply itself times 2, and then I'm going to, so actually there's some new stuff here, I should slow down. So this while, this word while is a Java keyword. It says I'm creating a loop, and basically means everything on the inside of these curly braces is going to repeat for as long as this statement is a true statement. So as long as the value exponent, which I declare here, right? I create the integer exponent, and I create the integer power, and they're assigned initial values of 2 and 1. As long as exponent is smaller than 40, this whole block of code will execute. So I'll print up power, and then power will be multiplied by 2, and then the exponent will be increased by 1. So the exponent will always be the power of 2 that we're printing up, and we'll print up 40 of these. Okay, so let's go check out, see what it looks like, compile. It worked. I don't know why that's highlighted. Main. And you'll see if I scroll up, these are the first two things I was playing around with, then you see all the powers of 2, 16, 28, blah, blah, it gets really big. And then look at this. Apparently, this positive power of 2, when you multiply it by 2, becomes a negative number. That's ridiculous. And then after that, it becomes 0. And it just keeps, when you keep multiplying by 2, it stays at 0. But somehow this went to this to give me negative, and this is 0. This is insane. Now what's going on here is that Java is only using 32 bits to represent integers. It's just hard-coded. It will never do anything different. That means there is a limited number of integers that it can represent. So if your values get too big for the int range, things are going to get unpredictable. And what happens here is, you can imagine if I have the number 2 in binary, that's just a 1 in the 2 slot. And if I multiply by 2, that 1 gets moved over to the 4 slot. Multiply by 2, it gets moved over to the 8 slot. And it just keeps moving over to the left until what happens? It just falls off the edge. And then this value right here is just the key, because the 1 that was all the way on the one that's been moving over towards the left, when it gets all the way to the left, it activates the bit that is representing plus or minus, kind of. That's not really true, but you could think of it like that. And it turns it to a negative. And then when you multiply by 2 again, it falls off the edge and it's completely gone, and the only thing that are left are zeros. So you have to be careful of staying within the valid int range, and the valid int range happens to be roughly negative 2.1 billion, and it goes all the way up to roughly 2.1 billion. So just make sure that your int values always stay within that int range. If they do, you'll never have any problems, but if they don't, you can get some craziness. This is called variable overflow, or I'm sorry, it's called integer overflow. All right, and that's another kind of problem that we have in dealing with finite sets of numbers, which is inherent to computing and not inherent to mathematics. So the mathematical symbols in Java: plus means plus, hyphen means subtraction, asterisk means multiplication, slash, the easy slash, if you move down with your pinky, means division. So those are all pretty straightforward. There's another one that's very useful in computing and doesn't come up in math a whole lot. This is modulus. Percent means modulus, and what that means is take the first number, divide it by the second number, but ignore the quotient. We're only going to keep the remainder. So in this case, for example, first integer mod, well, that's first real. If I modded 7 by 3, the result would be 1, because 7 divided by 3 has a remainder of 1. So then you can take any of those mathematical things and then reassign the variable. Like down here, that's what I'm doing here. I take this power integer, and what I'm doing is I'm saying multiply it by whatever's on the right side. So I take the current value of power times by 2 and reassign the variable. That's what it means. And you can do that with the plus equals, minus equals, times equals, divide equals, and you can even do modulus equals.